we're going to eliminate the parameter t and rewrite this system of equations right here as a Cartesian equation. So in other words, x equals something with y, or y equals something with x. Either way would work. And I want to do this two ways. One way is approaching it algebraically. Another way is approaching it graphically. And you'll see why both of them are useful methods. So I'm going to look at this equation right here. And first, let's write it a little bigger. X equals e to the negative 3t. And notice something similar between these two structures. If you look at this, this is e to the negative 3t. This one is really close. It's e to the negative 2t. Is there a way that I could rewrite this to make them look a little more similar? Well, how about this? What if we just raise each side of this equation to the 2/3 power? This requires you're a little comfortable with how exponents work, but by this point in the course, you ought to be. Now what happens there is I get this. X to the 2/3 equals, well, what happens here? You multiply the exponents together, right? You multiply negative 3t times 2/3, and that's going to give you e to the negative 2t. See, those 3's cancel out. And notice how that's almost the same as this equation we have at the bottom for y. Well, we just need one more step. I'm going to multiply each side by 3. Okay, and now look, it exactly matches. So this equals y. So there's one thing you could do. You could say, just using that method, 3x to the 2/3 equals y. Now another way you could write this would be as a x equals equation, right? So let's go through a couple more steps here. I could say x to the 2/3 equals y divided by 3, right? I just divided both sides by 3. And then I'm going to raise both sides. I'm going to do this exponent trick again. I'm going to raise both sides to the 3/2 power, the reciprocal of the exponent over the x. And now if you look what happens, see these exponents cancel out right here. Okay, so I just get x. X equals, well, I don't need to simplify this. This is about as simplified as it can get. Y over 3 to the 3/2. So that's another acceptable form of this equation. Either of these things will work. Now, if you know a bit about graphing or radicals or exponents, you'll recognize these are not exactly the same thing. The equation that I put in up here, I want to really make sure we note this. This equation has no domain restrictions, but this one does have domain restrictions. See this one that I'm pointing to, x equals blah, 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 that has a square root in it because of that divided by 2 in the exponent. So these are not exactly the same equation, and the reason you're going to get credit for both of these answers is because we are assuming that you are restricting your domain and range to make it appropriate, right? These equations will look the same over a certain interval. And let me give you an example. Let's see, if I were to graph, you know what? Let's do it this way. I was going to jump into a graph, but I like this method better. Let's graph it as a parametric system of equations. And you see I already got this started. I don't need to know what y equals 3x to the 2/3 power looks like when I have this system that I can graph right here. So take a look. I have an x, y coordinate point right there, and I'll just stick that on my graph, 1, 3, right? And I have a few more in here. And as you fill in this graph, you'll see something's going on here, which is that the graph is approaching 0. But as high as those values of t get, you cannot force this thing to have a negative x or y value, okay? Now, once you get this graph and you draw it, which you should be familiar with from all our practice with parametric graphs, you should be able to get the domain and the range just looking at this function. I'll leave that as a little exercise at the end of the problem for you.